So okay, so now we have calculated the here intensity of pressure. So now we will calculate the in the step number 6. Calculate thickness of the base plate. Calculate thickness of base plate. So for calculation of thickness of base plate, so first we have to calculate the moment arising due to the critical section. So as I told you, so this is the your gusset plate and column. Then this is the your sorry base plate and column. So this is your gusset plate. Then this is your angle section. So from this space, so this space C1 distance will be there. So C1 is nothing but here this C1 is equal to critical section. Critical section. It means the bending moment will be the occur here maximum and due to the failure this connection or section. So here we have to calculate first bending moment due to this critical section. So how to calculate? So bending moment M is equal to W into C1 square by 2. So this is the cantilever part. So in this cantilever part, the failure of the your section will be there due to the movement. So now intensity of pressure we have calculated, that is 8.96. Intensity of pressure 8.96 into C1. So now we have to measure the C1 distance. So how to measure C1 distance? As I told you, C1 is equal to overhang plus length of connected leg LC minus T, thickness of angle. So here overhang is we have considered as a 10 mm. Earlier in the step number 3 we have assumed the overhang 10 mm plus LC, length of connected leg, is 115. We have taken angle of 150 by 115 by 15. So this is the your LC and this is the your thickness. Are you getting? So here LC is 115 minus thickness. It means we have to this LC, this 115, this distance 115. From this we have to minus thickness. Then we will reach here. इथून ही थिकनेस मायनस केल्यानंतर या फेसला येणार आहे आपण, म्हणून 115 मधून ही थिकनेस मायनस केली, दॅट इज 15 mm थिकनेस. आर यू गेटिंग? सो नाउ कॅल्क्युलेट दिस C1. This 125 minus 15, it means 110 mm. So here 110 square by 2. So now tell me the movement. So calculate the moment. 8.96 into 110 square by 2. This will be the Newton mm. Moment Newton mm. How much this? 54208. 54208. So 54208 Newton mm. So this is the movement due in this critical section. So now we have to calculate the design moment, MD, moment of resistance. So now we have to calculate MD. So MD is equal to, formula is 1.2 into Fy divided by gamma m naught into JD. So as we know, the 1.2 into Fy divided by gamma m naught into, we have to calculate thickness. It means, as we have seen in the procedure, 1 into t square divided by 6 here. So now calculate first TMD here in terms of t square. Calculate MD by putting this value. MD is equal to 1.2 into, here Fy is MD is equal to 1.2 into Fy is 250 divided by gamma naught is 1.1 into 1 into t square divided by 6. So now calculate MD value in terms of t square. Tell me the answer. Do this calculation in terms of t square. 45.45. So this value is 45.45 t square. So now we have to calculate t thickness. So by equating m and md, here we will equate m and md. So m is here 54208. M is the 54208 is equal to MD is a 45.45 t square. So calculate thickness T. What is thickness? How much T? 34.54. 34.54 mm. But this is the thickness. See, right here one sentence. Okay. So now this is the thickness of plate. This thickness, this, but here and what, see, please see here what I am writing. But T is equal to total thickness. T is equal to total thickness with thickness of angle. It means what? Actually, this is the thickness of gusset plate. This is your angle. This is your angle. So this is the thickness of angle. So here we are calculating thickness of plate. It means now whatever thickness is come, this thickness is this. Are you getting? Thickness of angle आणि gusset plate या दोन्हीची मिळून ही thickness असते. This thickness will be the total thickness with the thickness of angle. So now thickness of plate is equal to total thickness minus thickness of angle. Thickness of angle. So here total thickness is a 34.54 minus thickness of angle is how much we have is 15 mm. So 34.54 minus 15. 34.54 minus 15, how much? Calculate it. So 19.54. So thickness of plate is 19.54 mm. So how much thickness of flange for ISHB 350? So this is the thickness of plate, and it should be less than thickness of flange. I think thickness of flanging is 11.6 mm for ISHB 350. Please verify. For ISHB 350, the thickness of flange will be the 11.6 mm. So this is safe. So here we will use 20 mm plate, 20 mm thick plate. Are you getting, everyone? Okay. So this is the your step number 5. Now step number 7. So in the step number 7, we have to use the anchor bolts. So here we will use, so write down here, use 20 mm diameter, 20 mm diameter anchor bolt. So use, instead of that you can write use four numbers of 20 mm diameter anchor bolts for holding. Use 4 numbers of 20 mm diameter anchor bolts for holding base plate, with concrete pedestal, with concrete pedestal with concrete pedestal. Okay, so now last step is remaining, that is step number 8. We have to design the bolted connection. So design of bolted connection. So while designing the bolted connection, we have to assume first grade of bolt. So we have to assume here, grade of bolt. Grade of bolt is 4.6. We will assume 4.6 grade, and in the problem statement 20 mm diameter bolt is given. Okay, so now Okay, okay. Here wrongly I have written. This will be the greater. This will be the greater. Okay, and it is correct. Okay, 19.654 will be the greater than the thickness of flange, and this answer will be the correct. Okay, so okay, and now uh, this last step, design of bolted connection. So for the design of bolted connection, we have to use here assume the first grade of bolt. So we have assumed here 4.6 grade bolt. So now first calculate design shear strength. Design shear strength. So design shear strength is equal to, how to calculate, n into anb into FUB divided by under root of 3 gamma m1. So n is the shear plane. So here only one shear plane is there. So 1 into nb pi by 4 into d 20 diameter. So nb is here, sorry. I think we are taking points, how much? 0.78, no? 0.78 into pi by 4 into 20 square is the ANB into FUB. So for 4.6 grade, how much FUB? It will be the 400 divided by under root of 3 into gamma M1 is 1.25. So tell me the shear strength now. So this will be the, how much shear strength of bolt? Shear strength of bolt. How much this calculation? 45.27. 45.27 into 10 raised to 3. 45.27. It means 10 raised to 3 means it will be kilonewton. Are you getting? Okay. So now second, design bearing strength. Bearing strength of bolt. So 2.5 into kb into d into t into fu divided by gamma m1. So here, how to calculate kb value? So we have to first here calculate kb. So kb is here, uh, we have calculated many times for this. So kb will be zero point 0.5 here. So put the value and find the 2.5 into kb is zero point 0.5. Again, d into t. D is the diameter of bolt. T into thickness. So now here we have to use the thickness of gusset plate, because we are designing the here gusset plate. So 16 thickness we have to use into fu is 410 divided by gamma m naught is 1.25. So are you getting which thickness here we have taken? So we have to design the gusset plate here. So is this gusset plate is safe for the bearing, that we have to calculate. So this 16 mm. Here we have to take thickness. Here not we have to take angle thickness. We have to take gusset plate thickness. So tell me the answer in again kilonewton. Okay, 131.2. 131.20 kilonewton is the bearing strength. So as per the procedure, the what is the design strength? Design strength of bolt is equal to design strength of bolt. Design strength of bolt is equal to what? Minimum of shearing strength and bearing strength. Minimum value of shearing and bearing strength. So design strength is equal to how much? 45.27 kilonewton is the design strength of the bolt. Now we have to calculate the here number of bolts. As I told you, so number of bolt is equal to, as I told you, 50% of load on column. 50% of load on column, because the half load directly going to the base plate and half load will be the connection. So connection, it means the bolted connection. So divided by design strength. Divided by design strength. So load half 1700 divided by 2 into 10 raised to 3. So total load is 1700 divided by 2 into 10 raised to 3. And design strength is the 45.27 into again 10 raised to 3. So here 10 raised to 3, 10 raised to 3 get cancelled. So now tell me the total number of bolts. So 18.77. 18.77. So this 18.77 volts we have to provide both sides. As I told you, so gusset thickness of gusset plate is provided this side and this side. So both side of column gusset plate is provided. So here this bolt we have to provide both the sides. So here this total bolts 18.77. It means we will assume 19, but this 19 will be the odd value. So we have to assume this bolt 20 numbers, so that we can use 10 this side and 10 this side. Are you getting? 18.77 is the odd value 19. So it means if we divide by 2, so 8.5, 8.5, like this we cannot use. Are you getting? So we have to provide 20 number of bolts. So 10 this side and 10 this side. So are you getting? So now wait. So here write down, hence provide 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 10 number of bolts 10 number of bolts each side, 10 number of bolts each side. It means 20 by 2 is equal to 10. So this 10 number of bolts we have to provide. So now how to provide this 10 number of bolts? So this 10 number of bolts we have to provide, and that we have to show by sketch. It means you can see now, if you see in the side view, like this. So this is your gusset plate, right? So this is your horizontal plane, this is vertical plane. So now 10s are there, so you can use 1 2 6 8 here and 2 here. So like this you can use. So this is the your so this is your uh, connection of the bolts. So total 10 bolts are there, so you can use vertically in the 4 rows 8 bolts, and only 2 rows in the horizontal plane, or you can use 3 rows here and 2 here. So here 4 bolts are, and here 6 bolts. So like this you can place the your bolts and do the bolted connection. So this is the your sketch or connection. So you have to show here, these are the how much 16 sorry 20 diameter. So 20 diameter, total 10 numbers of bolt. So like this is your ISHB 350 column. This is your gusset uh, base plate. So here angle will be there, this angle. Good. So here this side on this plate also. So in this way, to width, this is angle width 115, and this is the angle depth your 150. So I have drawn this in the side elevation. If we draw in the 3D, then you will get. So we have seen the 3D sketch in the design procedure. Are you getting? So in this way, you can design the bolted connection. So here we have seen the two examples, one on each, for this design of slab base and design of gusseted base is here. So here uh, today our syllabus is uh, ending of the design of steel structure. So we will upload these links of all the PDFs in your link design of sorry all the PDFs of our syllabus I will upload on your syllabus study material link. Okay, so everyone, please uh, do study hard for this subject for the examination. Also, I will send you, or we will solve the some MCQ examples if we get time, and I will upload also the MCQs of the chapter wise in your syllabus study material. So we will uh, close your here our syllabus. We will meet again if your any doubts or any other information you want. For that purpose, we will meet again. So thank you everyone. You have patiently listened for the whole uh, syllabus online, because this is very dangerous to learn online such subject, design of steel structure. So I hope, and I wish to you for your examination. Okay, thank you. I have taken your attendance, so I will update. So here our syllabus will be closed. We'll meet uh, in the many more lecture for the practice or any MCQ or any assignment related question. But today here I am declare here our syllabus is over. Okay, so thank you. So today we will stop here. Okay. I have taken attendance also.